Bismillahirrahmanirrahim. So, in the last class, we studied about the image formation in convex lens, right? And I showed you six different position for six different position of object for convex lens. Now, today we will see, inshallah, how the image is formed in concave lens. Okay. So, image formation in concave lens. So the deadline to submit the assignment was till today morning 9 o'clock. So the deadline has passed. I hope you already have submitted the assignment.
Yes, sir. স্যার এই শেপটা স্যার ড্র না করলে হয় না স্যার। এই শেপটা অনেক প্রবলেম স্যার ড্র করতে।
এটা
ইয়েস স্যার। স্যার অ্যাকুরেট ভাবে হয় না, নিচেরটা একটু বড় হয় উপরেরটা একটু ছোট হয়, তাই সমস্যা স্যার। ওইটা ঠিক আছে কনভেক্স লেন্সেরটা, বাট এটা একটু প্রবলেম।
কনকেভেটাও ঠিকই আসবে। তুমি সেম রেডিয়াস নিয়ে এখান থেকে একটা দিবা, ওদিক থেকেও মানে এই লাইনটা আগে আঁকবা। এই লাইনটা আগে এঁকে তারপরে এখান থেকে যে রেডিয়াস নিয়ে এটা দিবা, ওই দিক থেকে সেম রেডিয়াস নিয়ে এটা একটা দিবা, তারপরে লাইন টেনে দিবা। ইট উইল বি ওকে, কোনো সমস্যা নেই।
ওকে স্যার।
So for concave lens, we do not need to actually put the object at different position, because all the time we will get a virtual image only. So first ray that will incident on the concave lens, it will be parallel to principal axis, and after it is refracted, how it will go? Will it converge or diverge?
Diverge.
It will diverge. Now it will diverge in such a way that if you extend it backward, you will feel like that it is coming from the principal focus. Okay, so if you keep your eye over here, or somebody is seeing from here, he or she will feel like that the light ray is coming from this point. Okay, so it will be diverged in such a way that if you extend it backward, you will feel like that it is coming from the principal focus. Then another light ray will pass through the optical center, and it will pass as it is. Okay, it will not change its direction. Now as you can see, both the refracted ray, okay, they are diverging, they are moving away from each other, so they will never meet. So what will happen? If I want them to meet, then I have to extend one of them, at least one of them, backward. So then they will meet at a certain point. Okay, so if this point is P, here the image of P will be created, which we named as P prime. And if the object is PQ, then the image will also be here, Q prime, P prime, Q prime. This is the image. So can you tell me what is the nature of this image?
Sir, nature of the image is virtual.
Virtual, very good. Then
Direct.
Greatly diminished.
direct, and it is diminished. Very good.
Yeah, okay.
That means you have learned. Okay, very good. So virtual, erect, and diminished. Okay. Now, for all position that you can keep in front of concave lens, the image is going to be same. Now, if you are ever asked what is the position of the image, okay,
That you keep it is between the C and F, no? Principal focus and center of curvature.
no such position can be mentioned over here.
Sir,
Okay?
at principal focus.
Virtual, erect, and diminished. This is the image that you will get every time you get image in concave lens. Okay, so position can be said, the image will be on the same side of the lens that we have the object. Okay, so you see we have the object in this side, so image will be on this side. Okay, but when we have real image in lens, what will happen? the image that will be created, it will be on the other side. Okay, image and object, they will be on the opposite side of the lens. Do you feel any difference in the video quality today?
Yes, sir. You are much beautiful. And sir,
Too much
today
beautiful. Too much beautiful.
today you are seeing so much brightness, and the
Sir,
camera is
it's
so.
clear. The
It's much
writings
more
are clear.
clear. That's what he meant.
Yes, sir. Today's web camera or another thing.
Webcam,
Sir, today's yeah. That's why.
yellow yellow লাগতেছে, জানি না এসব জিনিস কিভাবে ফিক্স করতে হয়। ওকে, যাই হোক,
ভার্সিটিটা দূরে দূরে লাগে, এটাই সমস্যা, আর কোনো সমস্যা নেই।
একটু দূরে রাখতে হবে, নাইলে বেশি কাছে আনলে এই মাঝখানের পার্টটা একটু বেশি জুম হয়ে যায়। যাই হোক, okay, no problem. So this is how we form image in case of concave lens. Now sometimes they might ask you that show the image formation in concave lens. So it will come for 4 marks. Okay, it is less likely, but if it is there in the question, then how you have to answer? You have to draw this figure and you have to explain it. How you are going to give the explanation? Okay, it is already written in your book. Okay, page number concave, yes, I got it. The page number 260. Okay, 260. You can go through the explanation. You will just say whatever is happening, that the one light ray is incidenting parallel to principal axis. You have to give a name to this point. If this point is P, then you will say the light ray, the PT light ray will come parallel to the principal axis, and after incidenting it will be diverge. So, and then you will give another name to this point. Okay, maybe M. So, and it will be diverge in OM direction, and then another light ray will pass through the optical center and it will go straight. So if I extend OM backward, then what will happen? It will intersect PO at P prime point. So P prime will be the virtual image of P, and if I draw perpendicular on the principal axis, I will get Q prime. So P prime Q prime will be the virtual image of object PQ. Okay, so in this way, just whatever is happening, you will just explain. If you understand it, you can explain it. Okay. Acha, now let us go through some equation. Okay, so these equations you are already familiar with. Okay, that is 1 by V plus 1 by U is equal to 1 by F. Okay, so this V is the distance of the image, U is the distance of the object, and F is the distance of the principal focus, or we mention it as focal length. Do you have any doubt?
Want me to, what is B, sir? B, and you can say that one again. Forgot, sir.
B, this one.
Yeah.
This is distance of image.
Oh yeah. Now I'm this. So I was forget.
Distance of image from the lens, okay, or optical center. Then this is the distance of object. Distance of object, okay, from the optical center, and this is focal length. Acha, now the thing is we already studied about the sign convention. Oh, before I start talking about the sign convention, I don't think I need to discuss that anymore, because in reflection of light we already discussed about this, huh? Okay, now magnification, you studied this equation in reflection of light also. It is the same, minus V by U is equal to L prime by L. Same equation. Okay, now we need to know when V will be positive, V will be negative, or U will be positive, U will be negative, then L prime when it will be positive or negative, that way. Okay, so now U, for you, for the students in SSC level, for U is always positive. Okay, because U is the object, right? Distance of the object, and object is always real. Okay, So that is why for your case, we will consider the distance of object u to be always positive. But v, sometimes it will be positive and sometimes it will be negative. So if you remember, can you tell me when distance of image is considered positive?
When it is front of the mirror.
Yes, this is for mirror, okay? But when it is in front of the mirror, what is the type of, or what is the nature of the image? Is it real or virtual?
Real.
Real. That means whenever the image is real, we considered V to be positive. That will be the case here also, okay? So whenever V is, the image is real, okay? And if it is real, then definitely it will be inverted, but that's not the parameter that we will consider here. So when V will be considered negative, when the image is virtual. Understood? Okay. So whenever you are listing up the given information, you must be careful. In the question, plus minus will not be given. They will only tell you that the distance of image from the concave lens is 5 centimeter. Now you have to understand that they have mentioned concave lens, and in concave lens always we get virtual image. So if we always get virtual image, V is 5 centimeter plus or minus. Minus, because whenever the image is virtual, we will write minus. But in the question, they will not tell you that it is minus 5 centimeter. They will only mention concave lens. They will mention the distance 5 centimeter. So you have to understand that in concave lens, we get the virtual image. So that is why V will be equal to minus 5 centimeter. Also, in one case of convex lens, we will consider V to be negative. Can you tell me which one is the case? Convex lens.
6 number, right?
6 number.
Very good. The last one that we studied, right? So in convex lens, I showed you 6 diagram, right? So out of the 6 diagram, the first 5 gives us the real image. So V is positive for them. But the 6th one, when we keep the object at a distance less than focal length, that means the object is between the optical center and the principal focus. Okay, so that time what happens? The image is virtual. Now the question might state like this, that the focal length of this convex lens is 7 centimeter and the object is kept at 5 centimeter distance. Then you have to find the value of V or something, or maybe V will also be given that V is 10 centimeter, something like this. Now you have to understand that if the focal length is 7 centimeter and the object is kept at 5 centimeter, definitely the object is kept before the focal length, and that is the case in convex lens. We get virtual image. So as you know that this is here we are going to get the virtual image. V, if it is given 10 centimeter in the question, while listing up for solving the numerical problem, you have to write V is equal to minus 10 centimeter. Is it clear or not? Okay.
Yes, sir.
Yes.
So you know when you will get real image, you know when you will get virtual image. According to that, okay, you have to write. Sometime the teacher might be generous and it might be mentioned in the question that it is a virtual image. Then okay, you don't have to worry, you don't have to think further, you can directly just write V is equal to minus. But sometimes it will not be mentioned in the question that the image is virtual. From your knowledge, you have to understand that here we are going to get a virtual image. Okay, so be very careful. Huh? Now, again, L, that is the length of the object. We always considered it to be positive. Okay, length of the object, we consider it to be positive. Then L prime, if the image is erect, then we consider it to be positive. And if it is negative, the image is inverted, then we consider it to be negative. Okay, this is the same, just like reflection of light. Okay, in spherical mirror we saw this, that if the image is erect, L prime is positive. Is the image is inverted, then L prime is negative. Now let us try to find out, okay, what will be the sign of M. Okay, So we will put this data over here and we will see when the image is real and inverted. We already know that there are two possible scenarios, that image can be real and inverted, or it might be virtual and erect. Like this, real and erect, right? Or virtual and inverted, no cross multiplication here. So real and inverted, virtual and erect. So let us consider that our image is real and inverted. Let us consider our image is real and inverted. So if our image is real, then what will happen? Put m is equal to, we know that, minus v by u. So this v will be positive, right? As it is real, v is positive, and u, it is also positive. So as a result, positive by positive, it will be positive, then positive into negative, it will be negative, right? We get the value of m as negative. So know that magnification will give you a negative value when the image is real and inverted. Clear? Okay, and remember, this negative sign is in the formula itself. Okay, it's not the negative value of v. Okay, what will be the sign of v? That is totally separate thing. This negative will already is there in the equation. Okay, so we understood when the object is real and inverted, then it is negative. You might be asking, sir, why did you use this part? Why didn't you take this part? Using this part also, I can show you that when it is real and inverted, magnification will be negative. Let me show you. M is equal to, we know that, L prime by L, and there is no negative sign in front of that, right? Okay. So if L prime, we know that L prime will be negative when it is inverted, which is our case. We are talking about real and inverted. So if it is inverted, L prime is negative. So, okay, negative. L, we consider it to be always positive. Okay. So positive by negative, what is the answer?
Negative.
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 So that is why magnification will be negative. Doesn't matter whether you use this equation or this expression, you will always get magnification value negative when the image is real and inverted. Clear? Okay. Now let us talk about, virtual and erect. Let us see what is the sign of magnification we get. You can already, guess that it will be positive because it is negative, then the opposite one will be positive. But how to prove it mathematically? So see, we know that m is equal to minus v by u. Okay. Now, if the image is virtual, then v will be what? V will be negative.
Minus.
Negative.
I don't know.
Yes.
Okay.
Yes, sir.
V, it will be negative when it is virtual. So here V, it will not be positive anymore. It will be negative. Now you can see that minus minus, they will become plus. So magnification will be positive when the image is virtual. That goes, we can prove it using L prime by L, this expression also. So when the image is erect, right, L prime is considered to be positive. So you put L prime as positive something, plus by plus, it will give you plus only. So doesn't matter which expression you use, we will always get the value of m as positive if the image is virtual and erect. Okay, knowing these things are of utmost importance, because if you get your answer negative and you see that the image is virtual and erect, that means you have done some mistake. Okay, so you can recalculate and check whether you find whether you did the mistake. So understood? Clear?
Yes, sir.
Okay, very good. Anybody has any question from this magnification part? And the sign convention, this is the sign convention, okay, that which one to be considered positive, which one to be considered negative, depending on the situation. This is very important for mathematical problem, okay. There will be 2-3 creative if the school reopens and we go for the normal exam. There will be, you can expect at least two, and there might be three also, okay, creative from this single chapter only. So please try to understand very properly, okay. Acha. The next topic we are going to study, this topic, comes as question for 2 mark, okay. So let us try to understand. That is the identification of lens. Identification of lens. That means you have a lens in front of you and you have to identify it whether it is a convex lens or a concave lens. Now you might say, sir, it is very easy. I will touch the lens, and if I see that the middle part is wider and the end parts are narrower, then I can say this is convex lens. But this is the way we can identify the lens without even touching it, okay, without touching. If you want to identify the lens, then what is the technique? How can you do it? So for that, what you need to do, wherever the lens is, okay, look at that and place your finger behind, okay, place your finger, any finger, behind the lens in this way, very near to the lens, very near to the lens. Obviously the image will be virtual and it will be erect, but whether it will be magnified or diminished, that one will vary. Now as we are holding the finger very near to the object, then what will happen? We can consider that it is at a distance less than the focal length, right? So let us say the lens we have in front of us, okay. So if we hold a finger over here and we are looking from this side, okay, then what will happen? We know that if the object is kept before principal focus in case of a convex lens, that is the number 6 option, right? So we will get a magnified image, magnified. But if we get a diminished image, and that is the case, we saw a little bit ago, okay, we get a diminished image in case of concave lens, okay. So in both the cases you will get virtual image, in both the cases you will get erect image. So based on these two categories, you cannot actually differentiate. You have to differentiate based on whether the image is magnified or diminished. If the image that you see your finger to be magnified, it has become large, then you can say that, okay, the lens we have in front of us is a convex lens, convex. And if the finger seems to be getting smaller, okay, you put your finger very near to the lens and look from the opposite side, you see the finger seems to be diminished, that you can say that it is a concave lens. Is it clear? Okay, so based on magnified or diminished, we will take the decision. If anybody has any question to ask, this is the time to ask. No questions?
Sir,
Hello.
how to understand the object is diminished?
Whenever you see something through magnifying glass, you understand that the object seems to have got zoomed, right? মানে তুমি অবজেক্টটাকে বড় দেখো বা ছোট দেখো, এটা তো তুমি দেখলে বুঝতে পারবা না. You have this common sense, right? If you hold your finger in front of the lens, okay, sorry, you look from one side and you hold the finger on the other side of the lens, then when you are looking at the finger through the lens, definitely you will see either bigger finger or smaller finger. That sense you have, right? You have the idea how long your finger is, and then you will see the length of the image that seems to be smaller than your actual finger or greater than your actual finger. So looking at that, I hope you can guess whether it is magnified or diminished, right? Okay. Inshallah, if the school reopens, we will do this in person. Okay, we will put the lenses in front of us. Okay, even though we will know that what lens it is, but we will see that whatever we are learning is actually applicable or not. Inshallah.
Sir, school খুলার chance আছে?
Obviously, কি হবে কালকে কেউ বলতে পারে না, সো সবকিছুরই চান্স আছে, আল্লাহ জানে। চান্স আছে বাট গ্যারান্টি নেই, এটাই হচ্ছে কথা। ওকে, now the next topic that we are going to study is power of lens. Okay, this is very easy to calculate power of lens, and that will be the last topic of today. Power of a lens that is expressed by P, and it is the reciprocal of the focal length. It is the reciprocal of the focal length. So the unit of power is diopter. Diopter, and it is written in short as capital D. But if you want to get the unit of power as diopter, you have to make sure that your focal length is in meter. Your focal length is in meter, not in centimeter, not in kilometer. Please remember, okay? If I give you that the focal length of lens is 50 centimeter, and then I told you calculate the power of the lens, then first thing that you have to do, convert this centimeter into meter. So 50 centimeter, if you want to convert it into meter, you have to divide by 100, so it will be 0.5 meter. So now P will be is equal to 1 by F. We will put this value which is in meter, not this value which is in centimeter. Please remember, okay? If you use this value, very easy problem, but still you will get 0 mark, okay? So maybe 1 mark for writing the equation correct, but still there will be some mark reduction. So 1 by 0.5, that will be 2 diopter. And as the principal focus, if it is mentioned in the question that it is convex lens, then obviously F will be positive, no problem. So then power will also be plus 2D. But if it is mentioned in the question that it is concave lens, so for that, you will get minus 50. So it will be minus 0.5. So for that case, you will get minus 2 diopter, okay? So
স্যার এটা কি বলছেন আমার বলেন
diopter.
ডায়োপ্টার ওকে
Now many of us use glasses, right? And whenever someone asks what is the power of your glass, we say that minus 2.5, minus 0.5, and plus 2.5, minus 3. We say this number, right? But we never say the unit because we don't know it actually. This is what is the power, okay? Minus 2 diopter. Okay, so whenever next time people ask you what is the power of your lens or glass, you may say the unit also, okay? Not only minus 2 plus 2, you may say diopter also, okay? Inshallah. So this is the number that we say, okay, that this is the power, okay? So thank you very much. Kindly go through the definition. I have already said it, the reciprocal of the focal length is the power of the lens, okay? So that's it. But still go through the book, there is a detailed discussion about it, go through it, and if you have any doubt you may ask me in the following classes, no problem. And I will forward you a video on human eye, okay? Human eye, inshallah, watch that video, and hopefully in the next class we will talk about the defect of vision. The defect of vision, like people, those who are using glasses, definitely they have some defect of vision, right? They don't have the normal vision. So what is normal vision? When I can say that this person eye does not have any defect, when I can say that, and when I can say that this person has some defect, and if the person has defect, what kind of defect does it has? Depending on, some people cannot see the near object, they have to hold it further, the old people, and the young people, they cannot see the distance object, okay? So different type of problem, inshallah we will talk about it, and we will try to know that what type of problem are these and how can we find the remedy of this, inshallah. Very interesting.
স্যার আপনি বলছিলেন কিছু পিক দিবেন,
Here
সবগুলো টার্ম
ডেফিনেশন
ডেফিনিশন
পিকচার দিব, আমি তো ড্রয় করে দিছি বোর্ডে।
ডেফিনেশন
স্যার হ্যাঁ ফোকাল লেন্থ, তারপর অনেক কিছু ডেফিনেশন।
ও আচ্ছা, তোমাদের আগের বই থেকে, ওকে ইনশাআল্লাহ। ওকে Okay, so see you in the next class, inshallah. Assalamu alaikum wa rahmatullah wa barakatuhu.